Morning, everyone. Welcome to London and AngularConnect. I'm Jules, and I manage developer relations for the Angular team at Google. It's always an honor when I get asked to do a keynote, and then it gets a little stressful when I try to figure out how to weave a story when people in our audience are brand new to Angular, and others have been with us for a number of years. Are you laughing at me? It's a red button. Anyway, I hope over the next hour I share with you a little bit about how we on the Angular team think about Angular, some of the investments we've made over the course of the last year in Angular version 4 and Angular version 5, and then a little glimpse into the stuff we're working on for the future. So it seems like the right place to start is, what's Angular? Angular is a platform that makes it easy to build applications for the web, mobile, and desktop. Where we started with AngularJS as a framework, we've expanded our focus to include an integrated set of libraries, tools, and services that make a complete platform. So if you're a developer building a mobile consumer app with fancy animations, or you're a developer building business apps that span across large teams and large code bases, Angular has everything you need to be successful. Recently, the Angular team went on an offsite. We chose to go to Seattle. We had some meetings, we ate some great food, we saw killer sunset. We even took a sail on the Puget Sound. I took this picture from the back of our boat. But the most important thing we did while we were in Seattle was we established a set of core values for Angular, a mission statement, if you will. To build a platform where developers can build apps that users love to use, that developers love to build, and a community where everyone feels welcome with a spirit of inclusion and respect. I would argue that that last point is actually the most important, because the Angular community is the most important part of Angular, and it's a super powerful community. All of you build awesome things on our product, and you're a welcoming group. You genuinely want to see other people succeed. You openly share with each other and with us, and when there have been issues, we've been able to come together to find a resolution to protect, support each other, and even grow as human beings. They often say it's not what you say, but what you do, and what all of you do is amazing. It's people like Shamela Jacobs who created NG Girls. NG Girls provides workshops all over the world, including here at AngularConnect, and it helps women and girls approach a career in computer science. And Zach Chappell, who made it his personal mission to create a new type of Angular event, marrying diversity and Angular with NG Atlanta. At NG Atlanta, 28 of the 37 speakers self-identify as diversity speakers, and of those, 24 are women. We've seen exponential growth in our community over the past year, with meetups all over the world, including NG Houston to NG Japan, new conferences, new events, all embracing our Angular values of inclusivity, welcoming, and collaboration. Apologies. So we'd like to take a moment to thank all of you, every single one of you who creates this community, makes it as powerful and as amazing as it really is. So thank you. Last year, when I was here on stage with you, we had just released Angular to the world. And this year, we just released Angular version 5 last week. In the course of the last year, we've seen steady growth in our developer community. And as of yesterday, we have over 999,000 developers using Angular. Woohoo! As always, we base these numbers on the number of 30-day actives to our Angular I/O website. And earlier this year, we launched a new version of our website. It's now built as a progressive web app, so you can install it to your home screen. It uses a service worker, has way, way better search functionality, a completely new architecture that allows us to dynamically generate Angular's documentation from a unique blend of HTML and Angular components. Igor's going to tell you a little bit more about the design decisions behind Angular I/O. And don't miss Ward Bell and Jesus Rodriguez, two of the engineers who worked tirelessly to get this to production in their session later today. So when I think about getting in front of a group like this and trying to explain to you what Angular is and all of the pieces of Angular, I often find myself categorizing things into three distinct categories. Well, Angular, the framework, which is really the core of everything we do, the compiler, the view renderer. Angular's first-party features, which are really commonly used features across most apps. And then Angular Labs, which is a new initiative I'll cover a little bit later in the keynote. You can think of this as places where, or you can think of this as the experimental playground for Angular. The Angular framework, like I said, is really the base of everything, and it's the heart of Angular. It has a default architecture with declarative templating and a component model so your code is consistent and recognizable. It has features that we've invested in so that you can build at scale, types, common idioms so people can understand each other, a developer style guide so you're writing quality code, and it's all testable by default. For the past year, the team has been focused on making Angular smaller and faster. And so I'd like to invite Igor Minar to the stage to tell you a little bit about our investments and the design thinking behind it. Igor is the tech lead for Angular, arguably one of the most incredible people I've ever met. And if Mishko is the father of Angular, Igor is certainly its spirit.
Thank you. That was quite an introduction. I will need a minute to recover from this. How's everybody doing? Thanks for coming here to London. It's great to see you. Jules mentioned quite a bit about Angular, about the community, and she's going to talk about some of the Angular features that we worked on recently. What I would like to focus on is primarily the performance and the improvements we made in Angular throughout the recent years. Performance have been arguably one of the top goals of building Angular. We learned quite a bit from building Angularjs, the prior generation of the framework. We researched a lot of stuff and then found ways how to make things much faster. One thing that we realized very early on was that performance has many aspects. There is not a single metric, not a single number that can describe how fast an application is. And we need to focus on some of them that were the most impactful. So we decided to focus on two aspects of performance. The first one is startup performance, and the second one is runtime performance. As you'll see, these two are quite distinct, and the optimizations that we employ to optimize these are quite different. Let's start with the runtime performance, because this is the one that we attacked early on, and this is the one that informed the architecture and many of the underlying things in the framework. Runtime performance is all about how do we ensure that the view updates happens very quickly. Imagine you have a view with a table, and your user wants to sort or change the sorting order in this table. The framework needs to respond to this and reshuffle the rows as quickly as possible to meet this demand. This is what view updates are all about. There are also much more structural changes that can happen during the runtime. For example, route navigation, when the user navigates from one side of the application and one part of the application to another. During this request, the framework needs to go and tear down the existing tree hierarchy of components, rebuild a new one that is responsible for generating the view for this new view. We need to do this as fast as possible. And while we are doing all of these updates to the DOM, we also need to make sure that animations and scrolling remain smooth. The common mistake that many of the prior generation of web frameworks suffered from was that they generated too much garbage, and resulting in a lot of garbage collection that interfered with many of the things that were happening at runtime, resulting in jank and not very great user experience. Our general approach to runtime performance has been around static analysis and code generation. Through static analysis, we analyze the application, try to understand the intent of the developer, and try to generate code that is tailored to that particular application, to that particular view. Once we generate this code, we ensure that the code is as efficient as possible so that VM that interprets the code has an easy time optimizing it further. And the code that the VM executes does no manipulation that should be as efficient as possible. All of this while producing as little garbage as possible. I'm happy to say that the solution that we employed resulted in Angular being one of the top modern solutions for rendering web applications, especially when it comes to the runtime performance. But let's switch gears and talk about the startup time and startup performance. Startup performance is all about how quickly can we get pixels on the screen when the application is starting, and how quickly can we get the application to a state where it's capable of responding to the user input in a way that is meaningful to the user. And we also need to take into account what kind of things we can do to optimize the return visits, because there are many opportunities to do caching, and we can improve the startup performance further. In general, when we talk about the startup performance, we're talking about optimizing the critical rendering path. This is the path, this is the amount of work that the browser needs to do in order to generate the first view of the application and get into a state where it's capable of responding to user input in a meaningful way. The time it takes to do this is often referred to as time to interactive. And the best way to optimize time to interactive is either through network optimization, architecture optimization, or decreasing the JavaScript payload size. The last one is the one that has been big problem for many of the solutions on the front end, in the front-end world. And this is the one where we focused on quite a bit. In Angular version 2, we laid a foundation for many of the optimizations that came in later that allowed us to reduce this code size significantly. In version 2, we shipped something we refer to as ahead-of-time compiler, or AOT compiler. This is the compiler that is capable of running as a build step, where we are able to take all of the payload size that would otherwise we have to be shipped into the browser and keep it only on the build machines, with the result of producing the generated code that is then used to create an optimized payload size. This reduces the payload size because we don't need to ship the compiler to the browser, but it also removes a lot of work that would otherwise need to happen in the browser during the startup time. The AOT compiler also allows us to further optimize the payload size using ES module optimizations. ES modules is something that we adopted in version 2. When you look at how we ship Angular and how we build Angular applications, we try to push very hard on using ES modules. What are these ES modules and why are they so magical? So ES modules is a standard-based module system that is part of ES 2015 specification for the modern JavaScript. And the cool thing about this specification and this module system is that unlike the other module systems that we had before, this one is statically analyzable. This means that tools like Webpack and Rollup can easily take a look at files that comprise your application and understand the imports, the exports, and the overall structure of the application, and employ advanced optimizations like tree shaking, module concatenation, and code splitting that were very difficult or unreliable before. When we look at how we took this foundation that we laid in version 2 and took advantage of in version 4, we made quite a few big wins. Many of you reported that the upgrade from version 2 to version 4 was super smooth. It was basically just upgrading the version of the framework and the version of the compiler, rebuilding your application, and you were done. And in return, you got big size wins. Many of you reported 50 to 60% size reduction after upgrade to version 4. How did we do this? We actually completely rewrote the rendering layer in Angular in a way that was backwards compatible. We referred to this change view engine, and basically it comes down to the prior version of compiler would generate very sophisticated, very optimized code that was, however, very heavy, very verbose. With view engine, we're able to create very succinct data structures that reduce the amount of generated code by up to 80%, which makes a big impact on the overall payload size. Additionally, to making this change, we also changed how we structure and how we publish Angular for you to use it in your applications. We use a technique that we refer to as FESM, or flat ES modules. What it comes down to is basically taking all of the small files that comprise Angular, the framework, all of its different parts, and creating just a handful of files that are much more optimized and better to use for tools. So if you are importing things from like @angular/compiler, it's coming from a single file. Everything from this entry point is coming from a single file, which results in two important things. The build time is much faster because tools like Webpack and Rollup don't need to traverse hundreds or thousands of files that make up Angular, but can just take in this single file that is already pre-optimized. But additionally, because we created these pre-optimized files, we can reduce the amount of overhead that these internal module structures could otherwise create, reducing the payload size by 20 or 30%, depending on the application. But what I'm most excited about is the optimizations that we made in version 5 that we released just last week. We doubled down on our efforts to increase the startup performance. And as we started playing the iteration, we actually took a good look at how things work at Google and externally. And what we realized is that there was quite a big gap between the performance and the results we were getting from the internal toolchain and the results we were getting from the external toolchain. At Google, the toolchain is comprised of the build tool called Bazel. This is something that Jules and Rado is going to cover more in another talk at this conference. And Bazel calls into Closure Compiler for minification. We also have a custom code splitter that is not available externally. Externally, however, and primarily in the CLI, we use stack composed of Webpack and Uglify. So when we were looking at how could we bridge the gap between these two solutions, we decided on a two-pronged strategy. We decided that we want to start externalizing the tools that we have at Google so that developers that are interested in developing applications the same way as Google does have that possibility. We know that this is going to be a long-term strategy. It's going to take a while to do. So we also decided we need to do something that is much faster, something that will yield result much faster. And we decided to invest heavily into improving existing external toolchain. When we started analyzing how the external toolchain works, how Webpack, Uglify, and all these pieces work, it basically came down to this. When you write your application as the application source code that is then transpiled into JavaScript modules. This transpilation typically happens through TypeScript. These application-specific JavaScript modules then need to be combined with libraries coming from Angular, from Material, from other component vendors, RxJS, or what have you, into a single bundle. For this, we use a bundler, typically Webpack, or there are some other options. Webpack produces a JS bundle, and it can be a single file or multiple files, depending on how you set up your code splitting or chunking, what have you. And these files then passed into Uglify for minification. Uglify is the place where we minify the code, make it smaller, remove a lot of the code that is not used. And as we started looking where actually these optimizations happen, where the code removal happens, we came down to realization that there was a lot of work happening in the Webpack, specifically the tree shaking part, which comes down to finding just the modules that are necessary for your application and including those in the bundle. However, these modules can still contain code that is not needed for your application because the granularity of these modules varies. And this is where Webpack, where Uglify comes in play and identifies these pieces of the payload and removes them if they are not necessary. To our big surprise, we actually found that many of the parts of this toolchain didn't work well together. For example, we found that TypeScript would sometimes down-level code to ES5 in a way that would make it impossible for Uglify to remove it, even if it was not used by the application. We also found the same issue with Webpack, where Webpack would generate code that would retain unused code and bloat the final payload size. So we decided that we needed to address this. But in order to make good progress and understand how these optimizations work and what kind of impact we are having, we needed to have a sample application, a guinea pig. And this was around the time when we needed to rebuild Angular.io anyway. So what we decided to do was to rebuild Angular.io with the focus on making sure that we can use it as a test bed for many of the optimizations that we later shipped in Angular. Angular.io was rebuilt using Angular, the framework, Angular Material, Angular CLI. We also added Service Worker, and we hosted it on Firebase hosting, where we started experimenting with HTTP2 and other network optimizations. The great thing that we learned was that over the course of the last 6 months, we were able to significantly reduce the code size. How we did it? Let's take a look at some of the optimizations. As we started analyzing the payload size, we found that a good chunk of the payload was actually representing white space that developers authored in the original template of the Angular components. This white space is sometimes significant because it's used by style sheets and how the browser renders the DOM. But in many cases, it's not necessary. So we added optimization into the compiler that allows us to remove the white space when it's not necessary. This resulted in 8% decrease of the generated portion of the overall Angular I/O payload size. If you have a big application, we expect that this is going to be much more significant. Right now, this optimization is opt-in. You can opt in either at the component level using the property called preserve whitespace, or you can opt in at the application level using Angular compiler options in tsconfig. The next optimizations that we worked on came from actually outside of the Angular. It came from RxJS. We worked together with Ben Lesh and the RxJS community on shipping the next minor version of RxJS, version 5.5. In this version, we added support for ES modules. Previously, all of the versions of RxJS shipped with CommonJS modules. And what we noticed is that presence of such an important library in the application like Angular was causing lots of de-optimizations throughout the toolchain. So we decided to switch RxJS over to ES modules, which resulted in 21 kilobytes reduction in the Angular I/O application. Again, if you have a bigger application that uses more operators and more parts of RxJS, this can be much more significant. In addition to reducing the payload size through switching over to a different module system, we also introduced a new way of using operators. We refer to them as lettable operators. This is a new way of using operators in RxJS that is compatible with tree shaking and supports code splitting, which was problematic before. Another set of optimizations came from looking at the internals of Angular, especially the runtime part that is present in all the applications. What we found is, even though we wrote the runtime in modern JavaScript, we often need to transpile it back to ES5, which is commonly used when we ship the code to today's browsers for backwards compatibility. And when we do this, if the code contains very complex class structures, or if it contains classes with lots of getters and setters, this results in a lot of bloat that is unnecessary. So what we did is we refactored the internals of Angular, and without making changes to the public API, we were able to reduce the runtime times by another 30 kilobytes. The last big optimization that came, we refer to it as Build Optimizer, is actually part of CLI. What Build Optimizer does, it takes a look at the whole toolchain and tries to correct all of these issues that we identify. Build Optimizer does things like removes metadata that is not necessary once you're using AOT compilation. It finds duplicate code, often present if you're transpiling the ES 2015 code down to ES5, and removes it and keeps only one copy. It also corrects poorly transpiled code so that it's better available for dead code elimination if nothing in the application uses it. And lastly, and this was probably the most significant change we made, was we identify code that is side effect free and mark it as such so that Uglify can remove it if it's not used by the application. All of these optimizations resulted in big wins across all of those categories that we track when we focus on reducing the payload size. Over these 6 months, we were able to reduce the size of Angular I/O by more than 50%. But what is really cool about this, this is not just about Angular I/O. Everybody benefits from these changes, because all of these changes have been baked into Angular, RxJS, into CLI, and if you're using these, you will benefit in the same way. We were able to confirm these benefits from other teams, from teams like Ionic and Amadeus, that work with us very closely. And what I like quite a bit is that we didn't improve the situation just for Angular, we improved it for the whole ecosystem. Anybody who uses RxJS, anybody who uses TypeScript, Webpack, Source Map Explorer, and some other tools that we stumbled across will benefit from the work we've done over the last 6 months. We are nowhere finished yet. There's still a lot of stuff to be done. We have plans on how to improve efficiency of code splitting. We have ideas how we can make more of the code that you don't use available for dead code elimination. And we're looking for other opportunities how we can improve the whole ecosystem. The best part about all of this is, however, that you can take advantage of all these improvements right away. The upgrade to version 5 is very smooth. In many cases, it should be just updating the version of the framework and the compiler, rebuilding the application, and you should be done. If you have any problems, or if you have big wins, I would like to hear about it. Please ping me on Twitter or meet me here at the conference, and I'll be happy to talk about this. With that, let's invite Jules back on the stage.
All right, thanks, Igor. I hope I got that frog out of my throat for the rest of this, because that was a little painful for me. Okay, so let's move to talking about Angular's first-party features now. Okay, these are sets of features that are commonly used, or that we found are commonly used in most apps. And so for Angular, when we launched Angular last year, we focused on the top requests from our customers and the community and all of you. And these are features that we've built ourselves, so they're built with Angular. They work effortlessly together. They perform at the scale you expect of Google. And of course, we test them across hundreds of apps before we release them to you. So these are things like forms, whether you like template-driven forms or reactive forms, the router, so users can get around your app, I18N, and our recently released HTTP client that gives you an RPC mechanism to talk to the server. So don't miss tomorrow, where Kara Erickson will talk to you about one of the projects that she leads, Angular Forms, and Olivia Combe later today will talk to you about his work on internationalization. This clicker is not the greatest. The Angular CLI, as Igor has been mentioning it, is our command line interface that allows users or developers to get started building apps fast. It can scaffold your whole app, generate components and services, all aligned to Angular's best practices. As Igor mentioned, the CLI team's latest release is focused on build optimization, with better tree shaking, decorator removal, and faster compilation times. In this latest release, they've also added support for Angular Universal, integration with Webpack, and they've improved their help in case you get stuck. We have a new Angular animations library that allows you to build really stunning apps with multi-element coordinated animations with or without staggering, and you can combine this with route transitions, so animations can move from one route to another. The animations library uses JavaScript idioms, which allows you to create libraries of animations that you can have for your whole project, or even across your whole organization. And of course, all of this is testable, so you can write unit tests to ensure that the animation does what you expect the animation to do. If you'd like to hear more about Angular animations, join Lucas Rubicki later today. He's one of our Angular GDEs, and I happen to know that Matthias, who is the engineer behind Angular animations, flew to Phoenix and took Lucas on a rock climbing trip to prepare for this session, so I'm sure it's going to be really good. UI components are libraries of things like buttons and input boxes and tables that you can drop into your app. We have a team at Google that works on Angular Material, which is our UI component library, and it's based on material design. The majority of internal Google apps, of course, use Angular Material, but it also has a huge following externally. And I'm really pleased to tell you that yesterday, Angular Material went into its release candidacy. But UI components is a special category because often the UI component library that you use really defines the look and feel and even the brand of your app. So we're really pleased to have so many partners who are also building UI component libraries on top of Angular. VMware has Clarity, there's Prime Faces, there's Wijmo, and two of our sponsors here, Infogistics and Progress's Kendo UI. To learn more about Angular Material, you can join the Angular Material team today, where they'll be giving an Angular Material workshop, and tomorrow, where they'll be discussing the data table. But all of these cool things, they don't really matter if you can't reach your users where they are on the devices that they are in or on, and the network connectivity state that they have available to them. So we've also invested in ways that you can extend your reach. First, with Angular Universal, which is really concerned with how to get bits to the screen faster. With Angular Universal server-side rendering, users make a request to the server, and the server bootstraps your app and serializes the state of your app for any particular route. This results in a much smaller payload that gets sent back down to the client. In case of a user coming to your app, for example, the first time, the user can begin consuming the app while the rest of your app downloads in the background. The latest release of Angular Universal, just recently, includes support for state transfer. State transfer enables the application to reuse data collected by the server for rendering static HTML on the client in order to improve the time to interactive, which Igor was talking about earlier. We've also invested in ensuring that Angular is a great option for building progressive web apps. Progressive web apps are a method of building apps that provide the user with a more native mobile-like experience. And one of the top concerns for PWAs is re-engagement, or how do I get a user into my app and keep them coming back? So with PWAs, when a user visits your site a couple times, you can prompt them to add an icon to the home screen so they can find your app easier. And then when they come back, the app actually launches without the URL bar, so they get that native mobile-like experience. PWAs also support push notifications, so if the user gives you permission, you can send them notifications just like in a regular native mobile app. In Angular version 5, we also released a new service worker. Service workers allow you to cache data so that on a user's second visit to your app, they have a much faster load time, even if they're on a super flaky network. Service workers also provide you as the developer better controls for managing offline workflows. To learn more about progressive web apps and our new service worker, you can join Maxime, another of our Angular GDEs, later today. AngularJS, or Angular, evolved from AngularJS, and we as a team are committed to supporting developers still using AngularJS while we provide you a path to get to Angular. Over the last 7 years, there are literally hundreds of enterprise apps at Google that are built using AngularJS. If you want to get hired at Google, your recruiter uses an AngularJS app. You want to get paid after you're hired or get a raise, those are all AngularJS apps as well. If you want to launch a product, track your bugs, track your support tickets, all AngularJS apps that have been built over the last 7 years. We've been actively working with these teams to migrate their code to Angular, as well as working with teams internally at Google that are building new apps. And since the launch of Angular last year, sorry, I know the frog's back, 25% of internal code at Google is on Angular. And when Brad, our engineering director, first showed me this graph, I was like, this is super fake, dude. Why'd you give me this? But actually, the numbers are real. It's just that a pie chart doesn't tell you the whole story. So the interesting thing about these numbers is that the adoption of Angular internally at Google has happened faster than AngularJS ever did. Where it took us 7 years to reach the state we are today with AngularJS, it's only taken 1 year to get 25% of all Angular code at Google onto Angular version 5. Apps like Plex, which is an internal-only business intelligence platform that allows Googlers to explore petabytes of data. This app is a great example of using Angular at scale. It uses Angular, Angular material, animations, the router, forms, and 90% of Googlers use this app every month. It's a lot of Googlers and a lot of data. And the Shopping Express team first took a hybrid approach to migration with both their web presence and their responsive mobile app, but they are now fully over to Angular 5. And if you're a Google Cloud developer, you've probably used Google Cloud Console. This app was originally built in AngularJS, and the team is now moving components into Angular. So we learned a lot from these teams and all of you about the challenges with Upgrade. And we recognized that we needed to find multiple ways to approach migration. And so we recently released Upgrade Lite. With the original Upgrade, AngularJS and Angular had to be on the same page, and AngularJS had to run in the Angular zone. With Upgrade Lite, you bootstrap the two independently. Most often, you bootstrap AngularJS first, and then you lazily load Angular when a user visits a route that has Angular components. This lazy loading capability makes the app super responsive and fast, giving a better user experience. And it also provides you as a developer with a flexible way to approach migration, especially if you have very large code bases. To learn more about migration, make sure you catch Hasim Hussain from Microsoft. And he is going to be talking about a variety of ways that you can approach migration. And a really, really awesome session is going to be with Connie Wong and Jen Burry, who are two software engineers on Google Cloud Console. Google Cloud Console is one of the largest apps at Google. And they're going to share their experiences migrating 1 million plus lines of code from AngularJS to Angular. Last year when we were here, we committed to December, which basically meant that we were going to release 2 versions of Angular a year. When we were here, we also committed to easy updates as a core tenet of building Angular. We want these to be non-stressful events, as Igor mentioned earlier. And we've been pleased with our progress so far. Right now, 83% of all Angular sites are on Angular version 4 or above. We don't have numbers for version 5, because we just released it last week. But we've seen some positive results or sentiment on Twitter already, with people suggesting that it's super easy to get to 5 as well. And companies like Grubhub, TheMBA.com, and Forbes have all gone through these easy updates. Make sure you catch tomorrow's keynote, where Stephen Fluen, one of our developer advocates, is going to talk about some enterprise use cases, and he'll even have a special guest. So, we've talked about what Angular is, and we've talked about the investments we've made in Angular over the last year. So now I want to talk about some of the things we're building for the future. So we noticed that a few of you, not mentioning any names or pointing any fingers, but a few of you stalk our GitHub repos. You watch every line of code that we submit, and occasionally there's a question or two about what we might be up to. So we recently launched a new initiative called Angular Labs, and this is a way for us to share with you the work that we're doing, and you can think of these as experiments where we're really unsure of the outcome. But true to our open source values, we want to share it with you and get your feedback while we're working. So it kind of works like this. Someone comes up with an idea, crazy harebrained idea, a regular idea, and they create a design document, and then they iterate over that design document with their peers or the team, and then they seek approval. And sometimes they just die right here to stay bits and bytes in a Google Doc somewhere out there. But often, they get approval, and the team works together to start implementing these features. We have a few projects currently sitting in Angular Labs. I'm waiting for the picture down there to get taken. First, the CLI. So the CLI is built on a technology we call schematics. And these are templates, really, that are metadata-based that allow the CLI to do things like scaffold your app or generate that component. And we heard from you that while you really like the structure the CLI provides, that sometimes you need to extend our defaults, and in some cases, even replace them entirely. Schematics let you do this. If you'd like to hear about schematics and the Angular CLI in general, you can join the CLI team, who are all here, tomorrow in their session. You also heard Igor refer to the fact that we use a different build system at Google. The ABC project is that effort that he was mentioning to try to get this build system to you. At the heart of ABC is Bazel. And Bazel is super powerful because it supports multiple languages. So maybe your back end is in C# or Java or Go, and your front end is, of course, Angular. Bazel can build all these things together so that everything stays in sync. And it's built on a scalable infrastructure, so it's super performant even across large code bases the size of which we have at Google. To learn more about building applications like Google, join one of our Angular team members tomorrow. Rado will be giving a talk about all of his experience supporting teams. Another common thing we heard from our customers and big companies was the need for developers to customize a component. More common, actually, is the need for large companies to build their own component library that has their own specific company brand. And so much like schematics, the Angular Material team has been building the component dev kit. And this is really a base to build your own components, and it's the same base that Angular Material is built upon. So we've done a lot of the hard work for you. Things like accessibility, doing overlays, and fast performance scrolling. And it contains base components, like a table, so you can just pick it up, style it, or really make it do whatever you want. And the newest thing to Angular Labs is something near and dear to my heart. So I'm going to take a second and give you a personal story about how we got here. I spent many years as a developer targeting applications to the SharePoint platform. So I was really excited, I was actually elated, when the Microsoft SharePoint engineering team invited the Angular team to come to Redmond and talk about how Angular developers could leverage SharePoint's newest front-end framework called SPFX. And then sadness ensued, because we discovered that the way Angular works today wasn't really a good marriage for the way SPFX had been created. So we came back to Mountain View, we did some research, and we found out that this was not just a use case that was solely applicable to SharePoint. It was a use case we found over and over, really with any product that has its own orchestration layer. Google Sites, Google Analytics, Drupal. So Angular Elements is our newest Angular Labs, and what this allows you to do is use everything you know about Angular, but you wrap your component or your app in a custom element. So what this means is that the consumer does not need to know anything about Angular because we're just using web standards. So you can take these elements and drop 1 on a page, or 2 on a page, or 3 on a page, 4 or 5. This is a really powerful new feature that we're developing, and you can see it in action tomorrow with one of our other developer advocates, Rob Wormold. So I hope that we've given you a little bit about how we think about Angular. Igor shared with you a little bit about our design decisions across version 4 and version 5. And we've given you a glimpse of what we're looking at for the future. Our team comes here to see and meet all of you, hear your stories, help you with your issues. So please make sure you come find us. And no matter who you are, no matter what you love, you can sit with us. Thanks.